Hello students, welcome to our NECNTV YouTube channel. Today I am going to explain BEEE subject Unit 1, that is DC and AC circuits. This unit gives the information about all the basic concepts related to electrical components, Kirchhoff laws, Ohm's law, superposition theorem, phasor diagrams, impedance, power factor, etc. First, let us start with DC circuits. Electrical circuit elements. The three basic components are, we all know, R, L, C. Let us see the definitions of these three basic components. Resistor, R. Resistor is the element which opposes the flow of charge. Its units are ohms. Whereas inductor, it has the property to store the energy in the form of magnetic field. Its units are Henry. And capacitor, C. It stores the energy in the form of electric field. Its units are farads. Next, coming to Ohm's law. Ohm's law states that the electric current through a conductor between 2 points is directly proportional to the voltage across the 2 points. That means V is directly proportional to I. We can write the formula for the Ohm's law as V is equal to I into R, where V is equal to voltage, I is equal to current, and R is equal to resistance. Let's see the limitations of the Ohm's law. That is, it is applicable to the linear elements only. Ohm's law holds good for the linear elements only. And the second one is, at constant temperature only, Ohm's law can be explained. These are the limitations of Ohm's law. Next, coming to Kirchhoff laws. There are two Kirchhoff laws. First law KCL, second law is KVL. Let us see the first law KCL, Kirchhoff currents law. The definition for the KCL is sum of entering currents at a junction or a node point is equal to sum of currents leaving from the junction or particular node point. So formula we can write as I in is equal to I out. Whereas Kirchhoff second law, Kirchhoff voltage law, the definition for the KVL is the sum of electrical potential difference around any closed loop or a network is equal to 0. Formula for the KVL is summation of V is equal to 0. Next, coming to series and parallel combinations of circuits. Let us consider resistance elements are connected in series and connected in parallel. If the resistances are connected in series, that means series connection means one element is connected next to the another element, then the complete circuit can be called as series circuit, in which the current will flow through all the components are same. So the total voltage is nothing but the sum of individual voltages across the each element. For series circuit, the equivalent resistance formula can be written as R1 plus, R2 plus, R3 plus, and so on. Whereas in parallel circuits, all the components are connected across the same voltage source in parallelly, providing multiple paths for current. That means in all the components, the same voltage is going to represent. That means the currents are going to divide in all the paths. Formula for the parallel combination of resistances as can be written as 1 by R total is equal to 1 by R1 plus, 1 by R2 plus, 1 by R3 and so on, 1 by Rn. We can write the formula for the parallel combination circuits of resistors. Next, coming to superposition theorem. The statement for the superposition theorem is, in a linear circuit with multiple sources, the responses, that means voltage or current, the responses is the sum of the responses due to each source acting independently. That means the algebraic sum of all the responses across any element can be measured when the source is acting independently. It is nothing but superposition theorem. we can able to find voltage or current at a particular element using superposition theorem. Next, let us discuss about AC circuits. AC circuits. AC circuits and the AC waveform represented using sinusoidal waveform. So we can write the equation of AC voltage and AC current as V of t is equal to Vm sin omega t plus pi. And the equation for AC current I of t is equal to Im sin omega t plus pi, where Vm is equal to maximum voltage, Im is equal to maximum current, where omega is equal to angular frequency. Omega is equal to 2 pi into f, where f is equal to frequency and pi here is pi phase angle. Next, let us see the basic definitions in AC circuits. First of all, time period. The time taken for one complete cycle is called time period, and the formula for the time period is T equal to 1 by F. Next, frequency. Frequency, number of cycles per second is called as frequency. Units for the frequency is hertz. Relationship between the time period and frequency can be written as F is equal to 1 by T. Next, phase. Phase is denoted with the letter pi. The position of the waveform relative to time 0. Exactly at the time period 0, the waveform is measured and the angle between the time 0 and the position of the waveform is calculated as the angle phase. Next, phase difference. Difference in phase between any two signal, that is any two AC signals, we can call it as phase difference. Next, coming to the definition of average value of a AC waveform. Average value can be measured as mean value of the AC waveform for one complete cycle, and the V average formula is calculated as 2 Vm by pi. 2, 2 by pi can be calculated as 0.637 into Vm. Next, RMS value of AC voltage waveform, that is root mean square value of a AC waveform, and if it is measured mathematically, the formula will be IRMS is equal to 0.707 Im, whereas VRMS is equal to 0.707 Vm. Next, coming to the definition of form factor. Earlier, we have discussed about RMS value and average value. And the ratio of these RMS value and average value gives the value of form factor. That is nothing but form factor can be mathematically measured and the value is 1.11. Peak factor. Peak factor is the ratio of peak value to the RMS value, and the peak value measured as 1.414. Next, coming to the voltage and current relationships in our basic electrical elements R and C. In particular resistor element, voltage and current are in phase, are in same phase. That means in the phasor diagram we have to draw voltage and current on a same line. Whereas in inductor element, current lags voltage by 90 degrees. So that means V is leading the current by 90 degrees. So we have to draw the phasor diagram voltage by taking voltage as reference and current as lagging by 90 degrees. Whereas in capacitor circuit, current leads voltage by 90 degrees. That means in the phasor diagram, if we have taken voltage as reference, then current phasor have to draw leading 90 degrees with reference to voltage. Next, coming to the definition of impedance. Impedance is the total opposition of current flow in AC circuits, and it is represented as a complex number like Z is equal to R plus JX, where R is equal to resistance and X is equal to reactance. Coming to the definition of active power. Real power consumed in the circuit is called as active power. Its units are watts, and the formula for the power active power is P equal to VRMS into IRMS into cos pi. Whereas definition for the reactive power Q, power stored and released by inductors and capacitor measured in reactive volt amperes. Its units are var and it is denoted with the letter Q. Q is equal to Vrms into Irms into sin theta is the formula for the reactive power. Next, coming to apparent power. The apparent power is the total power in the circuit. That is nothing but vector combination of these real and reactive power will give the apparent power, and it is measured in volt amperes, VA. The formula for the apparent power is S is equal to Vrms into Irms. Next, coming to the definition of power factor. Power factor is the ratio of active power to the apparent power. That means active power P Vrms into Irms into cos pi divided by S means Vrms into Irms. So we will get the mathematical expression for the power factor PF is equal to cos pi.